Hello viewers, in today's session we are going to discuss one important property of Dirac delta function, and in this session we are going to prove this property of Dirac delta function involving the delta function and the first derivative of delta function, right? So we'll prove that the product of x and delta prime of x is equal to negative of delta x. So let us start. So in order to prove this property, we need to have some important results. So let us first list out the results here. The first one is the formula for integration by parts, that is integral u dv is given by uv minus v du, right? And the second result which is required to prove this property is this property of delta function, that is integral f of x delta of x dx is given by f of 0, right? So whenever we have a function f of x which is associated with the delta function, then the value of this integral, that is from minus infinity to infinity fx delta x dx is equal to the value of the function at the point x is equal to 0, because we can write delta x as delta x minus 0. So we can also write this integral in the form, that is minus infinity to infinity f of x, and here we have delta of x minus a dx. Then the value of this integral is equal to the value of this function at this point, right? So we have f of a, and in this case a is equal to 0. So these two important results are required to prove this property. So now consider a function f of x which is also known as a test function, right? And let us consider another function that is x delta prime of x, and let us construct an integral that is from minus infinity to infinity, and here we write f of x, and here we have x delta prime of x dx, right? So what we have done, we are taking a test function f of x and another function x delta prime of x. Now we can form an integral that is from minus infinity to infinity, and we have f of x x delta prime of x dx. So let us call this integral as I, right? Now we'll solve this integral to arrive at this property, right? And in order to solve this integral, we'll make use of this result which is known as integration by parts. So now here we have delta prime of x, right? So let us see the notation here, d by dx of delta prime of x. Here we can write delta x. So d by dx of delta x is equal to delta prime of x, right? So we can write d of delta x is equal to delta prime of x dx. So this term, that is delta prime of x dx, can now be replaced by this one. So we can now write this integral I as minus infinity to infinity, and we have f of x, and here we have x, and for delta prime of x dx we can now write d of delta x, which is same as the derivative of delta x. So now let us apply the method of integration by parts to this integral. So here this function may be taken as u, and this function may be taken as v. So our integral, it now becomes minus infinity to infinity, and here u is x times f of x, because we can write this x in front of f of x, and v is delta of x. So we have u dv, right? Now applying this rule, we can now write our integral I as the product of u and v. So u and v is given by x, f of x, and here we have delta x. So this is u and this is v minus integral v du. Now v is delta of x and du is the derivative of u, and here we have x f of x, right? Okay, and here since we have the limits minus infinity to infinity, so we can now write the limits. Here we have minus infinity to plus infinity, and here we have minus infinity to plus infinity. So now let us first consider this term. Now here the upper limit is plus infinity, the lower limit is minus infinity, and we know that the delta function, it tends to 0 when x tends to either plus infinity or x tends to minus infinity, right? So this term reduces to 0 because delta x tends to 0 when x tends to positive infinity or x tends to negative infinity. So this term reduces to 0, and here we can now write 0, and here we have the integral minus infinity to plus infinity delta of x, and here we have the derivative of x f of x, right? So here applying the product rule for differentiation, which is d of uv, that is u dv plus v du, right? So here we can now write x d of f of x, and then we have f of x and d of x. So now we can write minus, then we have minus infinity to plus infinity. Here we have delta of x, and now this is x and d fx. Now the derivative of f of x can be written as f prime of x and dx. So here we can now write f prime of x dx, and then here we have f of x and dx. So now multiplying these two terms by delta x, we have minus infinity to plus infinity. Now we have x f prime of x. Here we have delta of x dx, and then here we have the negative sign and minus infinity to plus infinity, and we have f of x delta of x and dx. So now our integral I is equal to the sum of these two integrals, right? So if we take the negative sign outside, then we have the sum of these two integrals. Now let us evaluate this integral with the help of this property, right? Now see, here we have the function x times f prime of x. So let us take x f prime of x as g of x. So this integral is now minus infinity to infinity, and here we have g of x delta of x dx, and here we can now write the positive sign, and we can write it as minus infinity to plus infinity, and here we have f of x, and we can take or we can combine this negative sign with the delta function. So we have minus delta of x, right? Okay, so now this integral can be evaluated through this property. So the value of this function, this integral, is equal to the value of the function g of x at x is equal to 0, because here we have delta x. So delta x can be written as delta of x minus 0. So we can now write here a g of 0, and here we have plus minus infinity to plus infinity f of x and delta minus delta of x. Now g of 0 can be evaluated from this expression. So when we take x is equal to 0, then we have g of 0 is equal to 0 multiplied with f prime of 0. So this is equal to 0. So now here we have 0, and then we have minus infinity to plus infinity f of x and minus delta of x dx. So this is now equal to minus infinity to plus infinity, and we have f of x and minus delta of x dx. So the value of the integral I is now equal to this integral. So now in the beginning we have assumed the integral I as minus infinity to infinity f of x, and here we have x delta prime of x dx, right? So this was our integral I, and through all these steps we have arrived at this integral, that is I is also equal to this integral. So we can now write minus infinity to infinity. Here we have f of x, and here we have minus delta of x and dx. Now if we compare both the sides, we can see that here we have f of x and here also we have f of x, right? So comparing both the integrals and comparing the integrands, here we have x times delta prime of x, and here we have minus delta x. So we can now write x delta prime of x is equal to minus delta of x, right? So by comparison of these two integrals, we can see that x delta prime of x is equal to minus delta of x. So this is how we can prove this important property of Dirac delta function.